Welcome back to Excel HQ, everyone. Today we will be creating a loan tracker while going over the functions PMT, IPMT, and PPMT, standing for payment, interest payment, and principal payment. We're going to get right into it, and we're going to be starting off with these three functions, and then we are going to be making the loan tracker after, because knowing these three functions is really going to help you understand how the loan tracker works, especially the amortization table. So let's start off with PMT, which just calculates payments for, let's say, a loan. So I'm going to type in equals PMT, open up my bracket, and my first prompt is my rate. What is my interest rate? It's going to be 5%. How often am I going to be paying back the bank? I'm going to be paying them back monthly, so I'm going to need to divide this by 12. Why? Because interest rates are usually stated in annual terms. So that means if I paid them back once a year, it would be 5%. However, I'm paying them back 12 times a year. So it's going to be 5% divided by 12. And my overall interest rate for the year, if I added it all up, is actually going to be smaller than 5% if I was to convert it to annual rate. And this is because the frequency of my payments is every other month or every month compared to every year. And since I'm paying back faster, my interest rate is actually not going to be as bad in the long term. And the same thing is for NPER, which means number of periods. So once again, over 5 years, that's going to be 12 months per year. So I'm going to times that by 12, since I'm paying it back 60 times. Now my present value is going to be $50,000. And then I'm going to close off my bracket, and that's the end of my statement. And it's going to give me negative $943. And the reason this is negative is because right now this loan, this is a cash inflow, it's coming to me. And then this is negative because this is a cash outflow. I'm giving it right back to them. And now you might have noticed a few other prompts here. This is my future value as well. It automatically assumes that your future value is zero. This is your payment if you want your principal to be zero by the time 60 periods are up. However, it doesn't have to be zero. Let's say I just put 1,000 here. What am I going to get? I'm going to get a payment of $958 instead of $943. That's all that is. And then if I go right back into it again, and my type, this is just whether it's at the end of the period or at the beginning of the period. Usually it's at the end of the period and the default is 0. However, beginning of the period, I just put in 1. So this just means, does it start January 1st or January 31st of the month? When do your payments start? Is it like 1 in? Which it usually is 1 in. If I take a loan out right now, I don't have to pay back, a significant portion of it as soon as I take it out. I have to pay it back the first month after. So the default's always going to be 0. So you don't really need to worry about future value or type in these cases for loans. And now the great thing about IPMT and PPMT is that it actually splits this up. So IPMT is just going to calculate our interest rate. If I can spell it right, and there we go, I can. All I have to do is put back in the exact same numbers. I'll have my period, but this is the extra prompt for PPMT and IPMT. And this is my period. This is my very first period. So if I borrowed money on January 1st and I'm paying it back on January 31st, the first payment I'm making back is just going to be 1. So what does my first interest payment look like? And then I'm going to have my years of 5 times 12 again. And then my present value, once again, is going to be $50,000. Close that off. And I'm going to get $208. That's my first interest payment. And interest payments go down over time as principal payments go up usually. So let's look at this. If I take out my 1 and put 60, what is my last interest payment going to be? It's going to be about $3, not much at all. And then if I calculate my PPMT, I just type in PPMT. This is for my principal amount. So this is just me repaying the $50,000. The interest payment is me paying back the interest on the $50,000 because that's what they're charging me in order to borrow this money. So right now, my rate, once again, is going to be 5% divided by 12. My PER, let's say this is 60 once again, and then my present value, or my NPER, is going to be 5 times 12, and my present value is going to be $50,000. Close off that bracket, and I get $939 out. let's say this is just my first period, and I get $735 out. So as time goes on, your interest payment gets smaller and your principal payment gets larger. Let's take this guy and put him back to our first period. So now that both of these are at their first period, if I added them together, let's say G3 plus I3, I get negative $943, which turns out to be my regular payment. And that is how interest payment and principal payment is connected to your overall payment. This function here is just the sum of your interest and your principal, except in your interest and principal, you can look at certain periods, at 20 months, it's going to be 147. This is going to be negative 795. However, the important thing is that every single month it will add up to $943. And that is basically how your PMT, IPMT, and PPMT function work. Now, let's get into our loan tracker on sheet 2 here. So really quickly, I'm just going to copy and paste some stuff in. Okay, I've went ahead and I've copy and pasted some stuff in. And this is going to be our first table tracking our loans. We can have more than one loan. And depending if we have more than one loan, we're going to have a loan ID for them as well. So let's just put one here for now. We'll work on the second one later. What's our loan amount? Let's say it's going to be $100,000. Our interest rate, let's say 4.5%. Years, how many years? Let's just say 5 years again to keep it simple. And our payment frequency. This is the first time that we're going to use another technique called data validation to create a list. A list because I just want to be able to pick whatever my payment frequency is in case I add more loans onto my table. I don't want the hassle of typing in monthly, it's just annoying. So over here, just on my right really quickly, I'm going to put in weekly. And I could do this on another sheet, but I'm just doing it here to show you. I'm going to put in bi-weekly. I'm going to put in monthly. And let's just say yearly. If there's anything else like quarterly or bi-monthly, you can put that in as well. But right now, we're just going to stick with these 4. I'm going to go to my payment frequency, to my data tab, data validation, quickly go to a list, and then list out my weekly to yearly. I'm going to click on OK. And then I get my drop-down menu, and we're just going to keep it monthly just because it's simple, easy to follow. Now onto my payments per year. I'm going to use an if statement really quickly. And what I'm just basically comparing is I want weekly to return 52, bi-weekly to return 26, monthly for 12, and then yearly for 1, just so I can get my payments per year. So I'll just simply click on my cell over here and then say, hey, if this equals weekly, and I'm going to put it in quotations because it is text. I want it to return me 52 because I'm going to be paying it 52 times. And then I'm going to do this 3 more times. I'm going to say, hey, if this equals, bi-weekly, then I want you to return me 26. If this equals monthly, I want you to return me 12. And lastly, if this equals yearly, I want you to return me 1. So does this work? It does work. Monthly equals 12. Let's go to bi-weekly. Bi-weekly equals 26. There we are. Now our first payment date, let's just assume Jan 31st, 2025. Why not? And our total amount of payments, this is just going to be our term times our payment per year. 60 total payments in total. It's very simple. Okay, I'm going to make this into a quick table. And we have our first table for our loan IDs. This is nice. All right, now we need to go on to our amortization table. So I'm just going to really quickly put loan ID here. And then I have 1 here. And then our table is actually going to start just right next to it. Let's say we start off with the period. We have our date. We have our beginning balance. After that, we're going to have our interest payment, our principal payment, our total payment, and then our ending balance. And these are all the necessary things to know. And we'll make a good table right here. So our loan ID is currently 1, and we're going to need to reference this for a period actually. So for a period, how many periods do we have? We're going to use a simple sequence dynamic array function, and it's going to be based off of how many total payments there are. However, what I want is that if my loan ID here says 2, I want it to look at the second loan and provide me that amortization table. So what I'm actually going to need to do is use my XLOOKUP function here. See, with my XLOOKUP function, I can look up my loan ID. I'll be sure to put that in $signs because I don't ever want that to move from C8. And then I'm going to look up my array in my table here. I'll click on loan ID. This is why this is important. This is in the table as well, or else you'd have to highlight your old table. And then maybe when you made another entry down here, it wouldn't recognize that. But since it's table 1 loan ID, it's going to recognize everything under the column. And then what do I need it to return? What I need it to return is 60. And this is just going to return the number 60. This is all this does. I don't need anything else in there. So then in my sequence, my rows are going to be 60. I don't need anything else. Close off that bracket. And then here are my 60 rows. Now to start off with my date, I'm going to be using the function eDate. And once again, I want my start date to be my first payment, but then I want every other date to increment by 1 month appropriately. So I'll use my XLOOKUP value again here. You're going to be seeing a lot of these XLOOKUP values in here. However, this is just the way I like to do it so I can always see, and it stays very organized this way as well. Return array, and I want it to return here. Close off my brackets. And then, can I close it off without ones? No, I cannot. So let's just say my period -1. What do I get? And then it doesn't return me my formatted version for some reason. Maybe because this is custom. Let's see if I change it to long. No, okay. So I'll just change this to long really quickly. There we go. January 31st, 2025. That's simple. What is our beginning balance? Straight up XLOOKUP statement again. 1. We're going to be looking it up on our loan ID. And then we're going to be returning our $100,000. There we are. Let's make this counting. And then our interest. So this is when our first formula comes in of the IPMT. You got to be able to spell it right or else it's not going to work. And then our rate, our 4.5% interest rate. And what it would actually be a smart thing to do is just say, hey, let's add on another part. Let's go adjusted interest rate. I'll double click on that to extend the column. And then we'll just do whatever our interest rate is divided by whatever our payments per year is. You know, the more we automate this, the nicer it'll be in the future when we put more loans in, turn this into a percentage. Let's see our decimals here. Okay, so 0.3% monthly, not too shabby. Let's go IPMT again. And we're going to have to do a lot of XLOOKUP statements here. XLOOKUP, our loan ID of 1, I would like to look it up in this column. I would like to return this column, finish that off. Our period, simply just going to be our period here for number 1. NPER, back to our XLOOKUP. Look up this value, make sure it's absolute, look up in this array, and return, what do we need to return here? Our 60 for our total payments. All right, and now our present value, which is just going to be another XLOOKUP. And then we're going to look up, well, I guess it could be our beginning balance. That might be a bit easier. So then our present value is just going to be our beginning balance. However, got to put the absolute value $signs around that as well. So then what do I get? Negative $375, which is correct. Now we'll go to our principal, PPMT. And what actually might be easier is just to copy and paste this over. What do I see here? I'll just, everything stays the same, or it should stay the same, except for E9, it just moved over a little bit. But if I just change my I to a P, everything else is constant. Here is my total principal payment. And a good way to actually make sure that this is right is if we just use the payment function really quickly. You know, what's our rate? What's our NPER? What's our PV? What does that give me? If I added these guys up, that equals the same as my PMT function, which means my interest and principal functions are correct. I'll just add these up. And that is how much money is going out. $1,864 every month to pay off my $100,000 loan over 5 years at a 4.5% interest rate. My ending balance is going to be my beginning balance here, and I'm going to add on my principal that I've paid back, which is $98,510.70. I'm only subtracting my principal here because this is just the principal is just me paying back my loan. The interest is me, paying for their services, whatnot, blah, blah, blah. But then my next beginning balance is just going to be my ending balance here. And then I can drag this all down. So I'll drag this guy down just by clicking on here. That should work. There we are. And then I could drag this guy down too. And then let's just drag these guys down. So it should go all the way to $0. There I am, $0. Here is your loan tracker. Here's your interest and principal payment each month. Here's your total payment by your days for whatever you need. All right, now, why do we do so much extra work? It's because let's say we want our second loan here. Let's say this loan is $1 million. And let's say this loan has a terrible interest rate. Terrible. But we're paying it back over, 50 years. That's a bit too much. 20 years. Payment frequency. Let's see. What do I want to pick? Let's pick bi-weekly. 26 payments a year. And then when's our first payment date? Let's assume it's going to be March 31st, 2025. And as soon as I put in March 31st, 2025, as you know, this will change my sequence here. Or actually, I have to do my loan ID. So right here, my loan ID. Now I'd like to see the amortization table for 2. And the first thing this changes is my date and my sequence, most importantly. If I go control all the way down here, see, I'm paying it back 520 separate occasions. I'll go back up to here, and then I just have to drag all these guys down. Let's see, what does this give me at the end of the day? At the end of the day, I'm at $0 again. And this is just a great way to track your loans, amortization. And, you can add as many loans as you want. I did it on the same sheet, so, I have limited space. However, you could just do it right next to each other or just on separate sheets. And you can have your loan table, your loan tracker. You know how to use your payment functions. And my job here is complete. If you enjoyed this video, make sure to give it a like and subscribe. And if there's anything you'd want to see in the future, make sure to comment down below.